In December of 2025, two of the most sensitive radio telescopes on the planet turned their attention toward a single object racing through our solar system, an ancient visitor that had arrived from somewhere else in the galaxy entirely. And for a combined total of hours, they listened. Not metaphorically, literally, scanning across a huge range of radio frequencies, hunting for the specific, narrow, artificial-sounding signal that would indicate something out there was actually transmitting. This wasn't a fringe operation, and it wasn't hype dressed up for a headline. It was a real, coordinated, professionally run search, conducted by two of the most respected techno-signature hunting programs on Earth. And what they found, when all of that listening was finished, deserves to be told honestly, because the honest version of this story is genuinely more interesting than the exaggerated one currently floating around online. The object at the center of all this attention is called 3I/Atlas, and its backstory alone explains why serious researchers were willing to point serious instruments at it. On July 1st, 2025, the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, detected a fast-moving object out near the orbit of Jupiter. Within days, follow-up observations confirmed something remarkable. This wasn't a native asteroid or comet belonging to our solar system. Its orbit was hyperbolic, meaning it had arrived from interstellar space on a one-way trajectory and would leave again the same way, never returning. It became only the third confirmed interstellar object in the entire history of astronomy, following Oumuamua in 2017 and Borisov in 2019. And its arrival triggered an enormous coordinated observation effort across nearly a dozen NASA missions, ground-based telescopes, and independent research teams, all racing to study it before it faded back out of reach for good. Given how rare these objects are, some researchers wanted to ask a very specific, very deliberate question about this one, a question that goes beyond ordinary astronomy and directly into the search for extraterrestrial intelligence. If an artificial probe, sent by some other civilization, were ever going to pass through our solar system, it would very plausibly resemble exactly this kind of object at first glance, arriving on an unpredictable, hyperbolic trajectory from interstellar space, easily mistaken for a natural comet or asteroid until proven otherwise. That possibility is precisely why Breakthrough Listen, one of the largest and most well-funded scientific programs ever dedicated to searching for radio evidence of extraterrestrial intelligence, decided this object was worth a dedicated, focused observation of its own. On December 18th, 2025, roughly one day before 3I/Atlas made its closest approach to Earth, the Breakthrough Listen team used the 100-meter Robert C. Byrd Green Bank Telescope, located in West Virginia and one of the largest fully steerable radio telescopes on the planet, to observe the object across a wide frequency range spanning 1 to 12 gigahertz. The logic behind the search was straightforward and grounded in real engineering principles, not speculation. As the researchers explained in their own published paper, any genuine artificial interstellar probe would most likely communicate, if it communicated at all, using narrowband radio signals, a specific, tightly focused type of transmission that's dramatically more efficient for sending information across enormous interstellar distances and considerably less likely to be scattered or absorbed along the way, compared to broader, less focused radio emissions. It's worth noting that this isn't pure guesswork either. It's the exact same basic transmission principle that every single spacecraft humanity itself has ever sent into deep space actually uses, including both Voyager probes, which continue to communicate with Earth using precisely this kind of narrowband signal even now, decades into their own journey through interstellar space. The Breakthrough Listen team completed their search, carefully scanning through the entire targeted frequency range, and their conclusion, published in their formal research paper, was direct and unambiguous. They found no credible detections of narrowband radio technosignatures originating from 3I/Atlas. Nothing. No unexplained signal, no unusual pattern. No candidate transmission worth flagging for any kind of follow-up observation. That result alone would already be a complete, honestly reported scientific outcome. But the Breakthrough Listen search wasn't actually the only one. A separate independent research effort used the SETI Institute's Allen Telescope Array, a specialized facility in Northern California, built specifically for exactly this kind of technosignature search, to conduct its own, entirely separate observation campaign targeting the same object, scanning across a similarly broad range of 1 to 9 gigahertz. This second search was considerably more data-intensive than it might initially sound. Over roughly 7.25 hours of observation time, researchers using a newly developed search pipeline called BLISS detected an initial pool of nearly 74 million individual narrowband signal hits within the collected data. Before anyone gets excited about that enormous number, it's important to understand what that figure actually represents, and why it doesn't mean what it might sound like at first. The vast, overwhelming majority of narrowband radio signals detected by any sensitive telescope on Earth don't come from anything genuinely mysterious at all. They come from ordinary human technology, cell towers, satellites, television and radio broadcasts, Wi-Fi networks, and countless other sources of what astronomers call radio frequency interference, a persistent background hum of artificial signals that any sufficiently sensitive instrument pointed at the sky will inevitably pick up in enormous quantities. Filtering that noise out from any genuinely interesting signal is one of the most fundamental, unavoidable challenges in this entire field of research. The research team applied exactly that kind of careful filtering process, working systematically to identify and remove signals matching known patterns of terrestrial interference. That process narrowed the original nearly 74 million hits down to approximately 2 million remaining candidates. From there, researchers applied a further, more sophisticated localization technique, a specialized piece of software called N-beam analysis, designed to determine whether a given signal's apparent position in the sky actually precisely matched the object being targeted, or whether it was more likely coming from some other unrelated source entirely. That step narrowed the list down dramatically further to just 211 remaining candidate signals. Each of those 211 signals then underwent direct, careful visual inspection by the research team, examined individually in what's called the time-frequency domain, essentially a detailed visual plot showing exactly how each signal's frequency behaved over the course of the observation. This is painstaking, genuinely tedious scientific work, exactly the kind of unglamorous, careful verification that real technosignature research actually requires. And after all of that filtering and all of that careful individual review, the team's final formal conclusion was, once again, direct and unambiguous. They did not find any signals worthy of additional follow-up. Because they found nothing definitively artificial, the researchers were able to do something scientifically valuable in its own right: calculate a meaningful upper limit on how powerful any hypothetical radio transmission from 3I/Atlas could possibly have been, given that their instruments didn't detect one. Their published results set that limit at somewhere between 10 and 110 watts of effective isotropic radiated power across the specific frequency and drift rate ranges their survey actually covered. In plain terms, that means if 3I/Atlas had been broadcasting a signal stronger than that specific threshold, within the frequency ranges these two telescopes were actually capable of detecting, it almost certainly would have shown up in the data. It didn't. It's worth being completely clear about what a null result like this actually means and what it doesn't. It does not and cannot prove with absolute certainty that 3I/Atlas is definitely completely natural, with zero possibility of anything unusual about it whatsoever. Science generally doesn't work by proving a negative with perfect universal certainty. What it does mean, and this matters enormously for actually understanding the current state of the science honestly, is that two separate, independent, professionally run search efforts, using two of the most capable radio telescopes specifically built for this exact purpose, looked directly and carefully for exactly the kind of signal a genuine artificial technology would most plausibly produce, and found nothing resembling one. Combined with the overwhelming body of separate evidence gathered by NASA's own coordinated observation campaign, chemistry data from James Webb and other telescopes, consistently showing this object behaving exactly like an unusually ancient, but entirely natural, comet, releasing gas and dust in direct response to solar heating precisely the way physics predicts, the radio silence detected by these two CD searches lines up with, and reinforces, the same overall picture. A genuinely remarkable, scientifically valuable natural visitor from another star system, not an artificial one. There's something genuinely worth appreciating in how this entire effort actually played out, beyond just the final result itself. Serious research institutions, backed by real funding, real telescope time, and real scientific rigor, treated the question seriously enough to actually go look, rather than simply assuming an answer in either direction without checking. That's precisely how legitimate scientific inquiry into extraterrestrial intelligence is actually supposed to work. Methodical, transparent, willing to publish a negative result exactly as clearly and honestly as a positive one would have been reported. Breakthrough, Listen, and the SETI Institute didn't quietly bury this search when it came up empty. They published their full methodology, their complete filtering process, and their final numerical conclusions in exactly the same rigorous, peer-reviewed format any other serious astronomical finding would require. 3I/Atlas made its closest approach to the Sun on October 29, 2025, and has been speeding back out toward interstellar space ever since, fading further from view with each passing month, carrying with it whatever remains still unresolved about its exact origin and formation history. But on the specific, narrow question these two research teams set out to answer, whether this particular interstellar visitor was broadcasting any detectable artificial radio signal back toward Earth, the answer, carefully verified and formally published, is simply and completely no. That's the real story behind the exaggerated headlines currently circulating about mysterious signals from outside our solar system. Not a cover-up, and not a quiet confirmation buried in the fine print somewhere. A genuine, well-funded, carefully executed scientific search, conducted precisely because the question was worth asking properly, concluding with a clear, honestly reported null result, exactly the kind of outcome real science produces far more often than the dramatic, headline-grabbing alternative, and exactly the kind of outcome that deserves to be reported just as clearly as a positive result would have been. If stories like this, the ones where real scientists actually go looking and report back honestly regardless of what they find, are what you come here for, stay close, because the search for something out there listening back is far from finished.